Thank you for having me, Alistair. And before we start, I just want to say I'm dialing in from the land of the Gallagher people, and I do join Alistair in the acknowledgement of country and pay my respect to the elders past, present, and emerging. So the title I've chosen for this webinar is about what wood could learn from steel and concrete. And one of the reasons why I've chosen this topic is I'm seeing over the last 20 years, specifically in the mass timber industry, actually lots of assumptions and lots of gut feelings driving decisions. So going back, just a quick introduction of myself and a bit of my journey, and to explain as well why I got to this title of the webinar. So over the last 20 years, I have been involved in more than 150 engineered and mass timber projects. And this is a snapshot out of the work we have been doing back then in the UK. And whilst being really in love with timber, and I started my career as a cabinet maker actually, and then turned into a master craftsman and studied industrial design and timber engineering. So there is certainly a very strong affinity to the material. But whilst doing all these beautiful timber buildings and being exposed to that environment, I had been actually living there. This is the Barbican in London, built around the 70s, started off 1968 and took about 10 years to complete, where 5,000 people are living. And I had the pleasure to live, and I moved around a bit in the Barbican, in this kind of, we call it concrete brutalist structure. I had an apartment there, and later on I moved up there. And it was beautiful. It was beautiful because the space was right. The space, the cross ventilation, the layout was perfect. So it's actually not that much material driven. And later on, I was watching quite a few movies, and I came across the Stadthaus. That's another house I would love to live in at some point and experience. And Stadthaus is a funny name. It's actually named after the family Stahl, who had been building that house in the 1960s, just above Los Angeles. It's a steel frame structure. And that steel frame structure gives you not only that incredible view, it gives you the big cantilevers, etc. And in translating the family name Stahl, which sounds very German, into English means steel. So the Stahl house had been building, the Stahl family had been building a steel house. At the same time, I found myself over and over again in very intriguing timber structures. And again, the space is right. And the space talks to you. And yes, the material is supporting that. In this case, it's the Kengo Kuma and Jeff Nee's Botanical Pavilion, which was on display in the NGV in Melbourne for quite a while. Interesting to experience. So if I look into that and recap my personal history over the 40 years I have been in that space, I actually have to admit, I love the beauty and the haptic experience of timber. I love the elegance of steel. And very early on in my industrial design practice and experience, I really loved the CNC-driven cutting, punching, laser cutting, water jet cutting, and CNC-driven folding of sheet metal. And I do love concrete benchtops, I have to admit. And with all of that comes always a very kind of specific smell of species, materials, process. And I'm still wondering what wood would do if it could. And that kind of relates a bit to certain limitations. I see kind of emerging more and more. The more we do, the more we learn in that space. And if wood could do it, wood what it would like, it would provide us raw material in abundance and a material which is stronger than steel. It would provide an environment for everybody to work with, easy to install, no discussion around sequestration, always ready for kind of disassembly because everything is a kit of parts, having a longevity of 400 years, no sweat. And companies would collaborate globally. And systems would be easy in terms of their connectivity and interoperability. Fire wouldn't be a problem, water wouldn't be a challenge, and it would be affordable. So that's what wood would do if it could. Today, we're obviously facing a slightly different situation. We have got raw material constraints and a volatile market, extremely volatile. We still see there's a cost premium because we don't seem to be tapping into the potential of really time saving and efficiency. And there's a big question mark around, what are we going to do with timber structures after the end of their lives? And I have to blame myself for that, and I'm guilty of preaching the same story about 10, 15 years ago, saying after its life, you can turn it into biomass. But meanwhile, with the whole carbon conversation, turning timber into biomass and burning it is probably not the best way forward, especially if we look into the material constraints we're facing. It's a similar challenge. And the fourth one, which we see, especially in the steel industry and the concrete industry, the collaboration, and there's a at a global scale and a sharing culture at a global scale has been developed way ahead of where the timber industry is today. And yes, there is a lot of work to be done in the building physics space, fire and water, just to name two of them. In the following slides, I will probably only cover and touch on 4 of these aspects, because building physics on their own will require a series of webinars, and happy to come back and happy to contribute further. So that's a bit of a summary of what to expect from the following slides. So if we look into the argument we bring forward on a regular basis, timber in abundance. If I just take a snapshot, and this is looking into global demand, and it's looking into the German consumption, or the consumption in Germany. So if you see the lumber demand has been kind of increasing significantly, and unfortunately this graph stops at the year 2020. It would be an interesting one to see how that curve actually has been developing in 2021. The diagrams are coming from the WWF and have been published in 2021. So there's quite a bit of consumption in millimeter cubes, and that's with our bark. So it goes back to the tree trunk with our bark for lumber, for timber products, and for pulp and paper. If I look into the German consumption, it's about close to 3 times as much as the global average. And if we again break it down to the German market and the availability of material, it's actually more than it's growing in Germany. So it's a heavy reliance on importation. So just to bear this in mind, if we design timber structures, where's the material coming from? How is it sourced? Are we really using it efficiently? And talking about efficiencies, in a way, just put up 3 lines here, look into the typical lumber or sawmilling process. And we know the process is not a very highly efficient process, whilst it's being very sophisticated. And I understand if we talk about here a conversion of 50 to 55% into lumber, the residue is still of value because it goes into other processes. At the same time, the residue potentially represents structural properties. So is there something we can look into slightly differently? LVL has got a slightly higher conversion, and the conversion could be increased, so always depending on the diameter of the core. Typically, the diameter of a core is still about 130 millimeters, 140 millimeters. If that core can be reduced down to 40 millimeters, then suddenly the conversion rate is increasing. And if we look into CLT as such, which a product we like, and it's not that dissimilar to glulam, the conversion rate from a tree triangle, from a log to the product, is actually very low. So obviously we have got the sawmilling process before, and there's an additional process in terms of planing and finger joining and cutting and routing, etc. So that's something to bear in mind. The other one from in terms of efficiency, I'm coming across over and over again, and people working with me know exactly where I'm coming from, saying, are we actually using standard section sizes? Very often we design towards a performance requirement, and we're not looking into what's the available at the market. So 240 is a great width of a glulam beam, and then 40 millimeters incremental in terms of height is a great starting point. But if you then suddenly apply what we all do on a regular basis from a performance and fire performance perspective, apply a jar layer, then obviously our effective residual section is decreasing. And depending on the section size, if we do the math, how much timber we're putting in as sacrificial layers is actually quite significant. So if you've got smaller section size and still want to achieve 90 minutes, I've got twice the amount of timber I need to put in. If I take, for example, a 480 by 480 column with an effective section size of 400 by 400 to allow for that jar, that means I'm adding 44% more timber to allow for jarring. So certainly something we should look into and should do more work. So I have been using the word efficiency or effective or effectiveness multiple times. But do we have got a good understanding? Because sometimes I've got a feeling we mix up effective or efficiency with productivity. So I think let's kind of simplify that. Efficiency is getting more out of the resources, is doing the same, as an alternative description, doing the same or more in less time. So efficiency is all about input and resource focused. And using here another example of a kind of way how markets are responding and material suppliers are responding. Obviously, putting a lot of concrete into slabs is not very effective. We're not using the material in the most efficient way. The bubble deck is one example. Bubble decks reduce, or call it void formers, reduce the amount of concrete without actually compromising the structural integrity significantly. So the amount of concrete reduction is very beneficial, even if we look into the whole carbon discussion. On the other hand, we all like the CLT product. The CLT product used the timber as the void formers, so it is a solid piece of timber. And very often, kind of, we did post-mortem analysis and looked into Stadthaus Murray Grove, for example, the first tall structure back then we didn't know what we're doing, so we took a very conservative approach. But the utilization of CLT as walls in certain areas, we had a utilization less than 10% from a structural performance perspective, and less than 10% means I've got 90% of excess material in a structure which could be used differently. So there are products emerging in the markets, and some of them haven't found their way to Australia as yet, and still have to find their ways across Europe. Just want to show here a couple of them. One of the products is a keelstake product, which is quite interesting because it uses timber in the void space. It's creating that distance between top and bottom chords, and it's actually providing stability as well in a horizontal situation. So it's an interesting product, and it can achieve quite significant spans. The other one on the right-hand side is a lignature, more kind of set system, but it's made out of solid timber pieces, which are just glued together. And what you can do in this case, and there's the section at the bottom, is you can utilize the void space for services distribution, for adding insulation for better acoustic performance, etc., etc. Certainly a product to look into. The other one, the industry always kind of faces as a stronger or a growing competitor, is the light gauge steel frame. And there's certain interesting advantages on a light gauge steel frame. It's a cold roll process, so it can be very material efficient. So if you look into the section I referred to earlier, the fascination about folding metal, which creates stability. So these section sizes are using very little metal. At the same time, I came across a while ago 3RT coming out of a Monash research project, now a company on its own. And 3RT kind of embarked on a journey, originally kind of manufacturing decorative timber products in a more efficient way. But I think in that way, how the product is manufactured is actually an interesting aspect. So I'm going to highlight here with the kind of two lines going through that block of timber, because 3RT is using layers of veneer and compressing the veneer whilst from one side whilst it's already constrained on the other side. And there suddenly you achieve that kind of folding structure, and folded timber as such will have got actually different properties in terms of the torsional and the bending aspect, not that dissimilar what you do with folding metal. So just to give you a bit of an idea what's actually happening in the industry and where opportunities lie. As Alistair mentioned before, we have been looking very closely into how we work with the Building 4.0 CRC, what are the research projects we're doing. And I just want to refer and touch on one. It's called a long span low carbon floor system. And we have been working here with Sumitomo Forestry, with the Building 4.0, with Monash University and the University of Melbourne. And the whole research program was led by the Future Building Initiative, which sits within Monash. And just name here Dr. Ivana Kuzmanovska, Duncan Maxwell, Victor Bunster. Victor has been looking very much into the low carbon aspect, and Dr. Angela Solati, she's a fire expert. So looking into long span low carbon floor system, not from a product development perspective, but from a benchmarking perspective. What is out there? What is out there globally? And how relevant can these products be for what we try to do from a Lendlease perspective across all our regions? So we looked into, again, initially say timber-based product must have a good carbon story. And we looked into timber concrete and timber steel structures as well. And that's kind of the summary finding of the different systems. And then we broke it down and say, let's select certain products. And here are the 9 products we selected. And as this was a benchmarking exercise, we used obviously a building which Lendlease had been delivering, the Daramu house. It's a 9x9 grid. And we used Stora Enso, CLT, open rib. We used the keel stake product. We used Lignatur as a product, the Stora Enso LVL close rib, and the Haslacher Brettstabe. And then we looked into timber concrete composites. And one of the criteria was, is that product available to the market? And so having timber concrete in situ, we didn't look into that because we thought about pouring concrete on site will actually slow down the whole process from an install perspective. So there's an acceleration requirement in which product are we gonna choose in for further research. Cree, I'm pretty sure many people heard about the Cree system, and then we looked into a TechSlab cassette. And in order to get a good view on benchmarking, we looked into what are actually the different criteria, and even that process defining criteria, and then looking into the weighing of the different criteria and the outcome of the research. So we looked into structure, vibration, carbon, fire, and we looked into production, availability, we looked into design, and within production, there is an element of transportation. We did a bit of a DfMA analysis. So how many panels can you put on a truck? What does it mean from an assembly perspective? And what are the alignment mechanisms? And then, yeah, there's certainly aspects of aesthetical potential, etc. So even just going through having these benchmarking criteria clearly mapped out and agree was already worthwhile the process. And to no surprise, obviously we didn't find a best in class. Best in class would have been, number 1 or 2 in every single criteria. But we saw obviously structural criteria, different front runners, fire, vibration, carbon. The whole carbon investigation was coming up with a big challenge, saying how much sequestration of timber can you allow. So we went through both scenarios with and without sequestration. And obviously, if we look into vibration, the concrete products typically come out as a front runner. In this case, we looked into without. That's where you see the Lignatur, Stora Enso, LVL, the keel stake listed as the top 3, because we have looked just from a timber perspective in this case. So that is just a snapshot, and that the whole report and the workings we have been doing with the researchers, I think we're going to make it available over the coming weeks and months. So we looked into, what's the structural depth, and you've seen that already in the previous slide deck here. There's actually a huge variation in terms of structural depth. We looked into stiffness over mass, and no surprise, obviously, concrete, because it's adding a significant amount of mass, comes out, I call it last. If we look into fire performance, then it's a completely different story. from a carbon perspective, and you see already there's some differences, in the left-hand side is actually with carbon sequestration, and the right-hand side without carbon sequestration. So timber still seems to be a bit of be ahead of other systems, but within the timber systems, you suddenly find once you go really solid, then from the reliance on sequestration is actually very high. So products with a lot of timber per meter square really are reliant on the allowance of sequestration in the carbon calculation. And what we found as well, if you do a proper LCA, the requirement, meanwhile, is to allow for sequestration in your LCA. You have to guarantee 100-year use of the product. Because we know once a timber product goes back into the recycling or the process of being potentially transformed into biomass, can be counterproductive. So we looked previously into efficiency. Now let's talk about productivity briefly. So productivity in simple terms is doing more in the same time frame. So it's very much output focused. And I've got a couple of case studies here. Most of you are well across projects like 25 King Street. And we used research for on another research project where we dissected actually 25 King Street a little bit further. However, this is one of my favorite slides of 25 King Street. Because what you see is still work in progress from an install perspective. There's the vertical structure still going up, columns and beams. The floors going in. And interestingly enough, the facade is actually one level below the superstructure. The facade, in this case, the facade has been chasing the superstructure, which is, a great outcome. But if we look very closely in then the subsequent success of the project is we left the DfMA approach and that interaction between facade and structure with facade and structure. As soon as it came down to the services trade, we did everything in a traditional way. So one of the questions back to researchers was, is there a critical mass required to really achieve time and program savings? And if we look into the very high level cost structure of construction, we see superstructure is probably somewhere around 15%, facade somewhere around 20%, services is around 25%. So the conclusion here is actually to really achieve program savings, it needs to be more than one or two trades driving prefabrication. You have to look into the whole project life cycle. You have to look into the whole value chain of a built project. So bringing services into equation for commercial buildings, absolutely essential to drive program savings and therefore cost savings to offset slightly higher cost of the superstructure. The other project many people of you have seen, the ANU, in this case the student accommodation building, BVN architects, very similar situation. And some interesting learning here as well I would like to share. What we see, obviously, great outcome, a CLT superstructure going up very fast. And it's actually, in this case, the facade system has been a bit slower. But on the other hand, one of the big learnings out of this project is the facade installer was not a different company to the superstructure installer. It was actually the same. So integrating trades from an installer perspective or assembly perspective was absolutely crucial. The other interesting learning out of this project is, and I kind of highlighted 3 of these building blocks. That's the top right-hand corner. You see the whole precinct. These have been timber structures, obviously based on a concrete basement, concrete commercial ground floor, as you can see in the diagram here. For the student accommodation, the B155 is a teaching and learning building out of timber. For the business, the only chance to deliver this project in a very tight time frame was actually diversifying the building systems. So by not having everything built in concrete, but having some of the buildings as a concrete structure, concrete steel structure, and some of the buildings in timber structure, the diversification of the systems made that possible, because suddenly you have got access to other trades, to more trades you can bring in, and you're not having that bottleneck of a concrete supplier, a form worker, reinforcement supply, which will be at a project of that scale, will be heavily burdened. And the other one I mentioned before, actually the installer of superstructure is the facade installer at the same time. So that's a very good observation out of this project. And that gave us the possibility to meet both time and then cost requirements. So just in other words, what I described, and we went through a bit of that journey of what is efficiency, what is productivity, and how they actually interlinked. I'm referring here to Little's law. Goes back not to Little John, but to John Little, who came up with that kind of, slightly simplified diagram. We look into input and output, and very often we kind of try to push more and more through the call it the side or the work in progress to get more output. But actually, that's not a way how we can increase output, because we are at risk to really jam-pack the work in progress, and we'll block the pipeline. So to look into how can we improve output is actually you have to look into what's in work in progress and what's happening there, and can we reduce the cycle time? And reduction of cycle time will mean we get more output, and therefore we can pull more input. So that's a bit of a kind of summary which wraps up that. Do we understand efficiency, productivity? How do we get to more and better output? Is actually we have to look into the throughput and the relevant cycle time aspect. And coming to cycle times, connections and connectivity is actually an important part. And I'm going to show you a very quick video here. And that video is coming out of Germany, and sorry about the German text. It talks about the HCW connector, which has been developed in collaboration between Baufritz and timber frame companies or house builders and Hilti in Europe. And what that shows here is actually the connector has got such an important role in the efficiency and subsequently productivity, or call it according to Little's law, the throughput on the building side, because it takes out about 30% of labor, and it's accelerating the setting out by utilizing the relevant tools and no surprise, and pretty sure other companies will follow that soon. There's a direct relationship between the connector, the design model, the fabrication, how the setting out and the tools for the applying the connectors. All of that is completely interlinked. And these connectors work from timber to timber, concrete to timber. And for me, it's very interesting to see actually a company coming out of originally creating tools to drill holes into concrete, and then becoming a world leader in fasteners into and concrete anchors, fasteners into concrete. Now kind of embarking on a journey towards towards applying their knowledge in the timber world. So again, that's a snapshot of that specific connector. There is another reason why I kind of showed that video. I think that specific connector we have seen, the HCW, I think is relevant for everything we do here in Australia as well. From a house building perspective, I think he has got its place in the low to mid-rise. But if we look into the mass market, we have been looking into how can we improve our throughput on building sites? How can we shorten the install time? And we always talk about hook time in this case, and hook time being the bottleneck. So if you put up structures, if you put up a column, you put up the column and then you have to temporarily brace the column before you can actually release the hook again. So can we develop a self-propping column, a self-propping connector for columns? And the same is then the connector for beams meeting columns. And this is a collaboration between Lendlease and Helms, and subsequently WoodSolutions out of New Zealand. And subsequently, we engage with Hilti as being the manufacturer and the distributor of the product. So that self-propping connector is kind of allowing us a 5 to 10 times faster install time on site. And that's significant. And that's increasing, again, what we saw earlier, throughput significantly. So I covered that briefly already, connection and connectivity. And again, looking into how that connectivity will play a role and where technology will play a role in the future from a digital platform perspective. I'm not going into too much detail because digital platforms could be another topic for webinar, but it's all about bringing the decision points. And a lot of us talking about early engagement, but let's bring the knowledge and clarity around when do we have to make which decision right up front into the process. And that's what our platforms will enable us to do. Other topic which will be coming thick and fast, circular economy, the reuse of products. The other big topic, ESG, environmental, social, and governance. And if you look into some just of the line items, looks into materials, looks into resources, looks into resource efficiency, waste management, water consumption, etc., and covers all the aspects of supply chain management, procurement, diversity, equality, and ethics. So it's the first time I see in my life that actually call it the original intention of sustainability is now driven by an incentive and not perceived as a cost burden. Because the incentive through ESG comes through the capital markets. Once you're ESG compliant or you outperform ESG requirements, the access to capital will be much easier. And that's certainly something to keep an eye on in the very near future. This is coming for the Australian market, thick and fast. I think it has arrived already in Europe, and there's more to be expected. And just to close out, I haven't seen many buildings which have been actually designed for disassembly. And that's a good example. And Courtney Stoelmacher, a architectural practice out of Holland, have been my early heroes in that space. They have been building that little parasite on top of a warehouse. And that was already with the intention it will move on. That's a CLT structure. The other one, again, it's more of temporary nature, and temporary nature drives thinking around disassembly. The Mk40 Tower by Daramu architects, where we have been challenging ourselves there. We can't anchor things in the ground. So how can we make sure once people are going up and down and there's wind, that tower is not falling over? So that tower was kind of in place for a year, was dismantled, was put up another place, was dismantled, and I think it found its final home in the meantime. Very similar to Parasite, reused over and over again. And by closing, just we're putting ourselves as Lendlease actually under significant pressure, because we came up with our mission zero and then the embedded carbon targets by 2025 net zero. And net zero here looks into scope 1 and 2, looks into what kind of energy we're using. Are we still burning diesel and burning gas? But from 2040 onwards, we're going to measure ourselves differently, because it will be saying, we will be saying absolute zero, not net zero, absolute zero for scope 1 and 2 and 3, which actually looks very deeply into materials and materiality. Where's material coming from? How is it used? Can it be reused, etc., etc. So I'm coming to the end. So to leave a bit of time for discussion and questions, just a snapshot and a reminder. Whilst people haven't heard much of Lendlease in the last couple of years about timber structures, Daramu House with Alex Sands architects, I think it's still an outstanding building and full of lessons learned. And it's a great environment to work in. And if we recap Lendlease's journey over the last 10 years, because if you go back 2012, we started with the Forte building down in Melbourne. We now have delivered to date we have delivered 20 engineered timber buildings across 3 regions. And those regions we operate in Americas, United Kingdom and Australia. And we're still learning. So that's something we certainly should take on board. There's so much work to be done. And there's so much work to be done we can't do in isolation. I know 10 years ago we have been doing this quietly before we have been delivering the Forte building down in Melbourne, but we can't do it on our own. So we have to tap into research, we have to tap into collaborations, and the Building 4.0 is a great chance for collaboration. We have been now embarking on a number of research projects with partners, just to name Sumitomo Forestry again, or H.G. Coombs in the services space, etc. So we're still on the learning curve, and looking forward to more to come. Thank you.
Thanks, Karl-Heinz. That was an absolutely amazing presentation. So everyone out there, if you've got some questions, please stick them into the Q&A. Just to start them off, Karl-Heinz, I was really interested in your slide there near the end about Lendlease's Mission Zero. That is a pretty challenging sort of benchmarks they'd put out there. How much would Lendlease see timber buildings in sort of assisting to achieve some of that?
Good question, Alistair. We kind of openly admitted 12 months ago when we put out these targets that we actually don't know how we get there. Since then, we're working a lot on really getting a good understanding of not only life cycle assessments, but the whole world of carbon calculation and carbon accounting. I think we're very confident about the 2025 goal with being net zero carbon. There's still a lot of kind of offsetting which can be done. To get to the 2040 goal, it's very clear we have to take, not only have to take, we have to go on a journey together with the supply chain. And we're running different scenarios. So if we're not doing anything, we never get there. If we look into how much of our pipeline could we utilize for mass timber structures or engineered timber structures, looking into 20%, 40%. We look into a 40% allocation and making sure at the same time we're really working with the steel and concrete industry and the supply chain, looking into where's the aluminium coming from, you know, how is hydrogen playing a role in all of that. That's going to be essential. So the scenario we have been building at this moment is certainly it's quite a portion of the pipeline needs to be allocated. With a little disclaimer, we have relied in this case on the sequestration, which in its own is a big challenge.
Well, one of the attendees actually sort of asked a similar question there in terms of your absolute zero. How do you see concrete playing a part in the business, and how would that look? Because it's a challenge for concrete. I mean, physically, you're going to produce a lot of CO2 just from the production of cement.
Again, if we look into concrete, it's a very similar scenario. Right? So we're obviously working with the supply chain and with the industries. We're looking into green concrete. We're looking into what's going into the concrete. So Melbourne University is doing great work in that space. And it's not always about replacing material, but making sure we find a good pathway. So looking into where's the energy coming from for the concrete production, for example. That's the big challenge. Very similar in the steel world. We're learning a lot in terms of how often can you actually recycle steel? How often can you get a steel beam back into the process? I think there are limitations there as well. And the industry seems to be, both steel and concrete seems to be well set up and pushing hard on their carbon strategies. In the timber world, I do not want to be too negative at all, but sometimes I've got a feeling we just reliant on it's kind of, you know, it's given to us by nature. Right? It's a growing material, so we kind of automatically go into so it must be good. But I think you may recall the question I have been putting out at the timber offsite construction conference early in the year, where I've been saying, have we got clarity and certainty of who owns the sequestered carbon? Because a lot of the forests and plantation forests are actually used as carbon credit schemes as well. So are we at risk to double counting? So there's a lot of work required and to create a relevant transparency, and then it's about traceability, etc.
That's a really interesting time at the moment with embodied carbon. Well, we've got a few questions here from the audience. I'll put to you, Karl-Heinz. So one from Christopher, just asking about the self-propping columns. They definitely sound like a major step forward. He'd be interested to hear about the limitations in terms of minimum dimensions and the amount of post-tensioning required, assuming that's a method used.
No, it's not a method of post-tensioning. We call it a quick connect, and unfortunately, I couldn't release more imagery around that. what it will, it's the connection will then act as a tie. The interesting part is you can release that connection point, so from a disassembly perspective. And that's certainly a space for the audience to watch. We're getting closer and closer to, in this case, Hilti is getting closer and closer because we kind of passed that part of the development onto Hilti, and Hilti is still working with homes. From a land lease perspective, it was more about identifying actually there is a significant challenge we want to address. We embarked on that and finding the right partners and then passing the IP on. So certainly a space to watch very carefully. The self-propping, from my perspective, is such a good example, because if you look at the value chain or the that stream, so you have to bring the props to the site, you have to store the props, you can pick up the props, you temporarily fix them, you take the props away once the structure is sorted, and then you repair the finishes, and you have to move it around again. So if you can get rid of all that work, that's not only an acceleration of time, but it's just a reduction of cost. Significant. And I'm more than happy to pay a little bit more for such a neat connector. From a performance perspective, the connector has been originally designed for high seismic loads. So because we looked into it specifically for the California market, we had a number of conversations with Sumitomo Forestry for the Japanese market, and it kind of seems to tick all, if not most of the boxes.
And you mentioned through your presentation, Karl-Heinz, about a number of the different new products that have been developed over in Europe that you looked at under the CRC, and also that Hilti technology in terms of installation. Is some of those products and systems available in Australia at the moment?
Hilti is certainly interested to bring the product into the market, and I think the audience is kind of more than encouraged to reach out to the local Hilti guys and say, can you share more about the HCW connector? That's certainly happening. From a timber-based product perspective, what we still see, the likes of Keel Stake or Lignatur, they are more kind of medium-sized operations. The Keel Stake is currently not available for the Australian market. I think BVN have been doing a bit of work with Lignatur in the past. But it's more kind of, I would say, an encouragement to the local industry to look into, can we actually adopt some of these products for the Australian market? And sometimes it's just, we don't have to do it all ourselves. Let's collaborate. Again, can we license the technology? Can we modify the technology for our purpose?
There's a question here around services, and I must admit that struck a chord with me when you were talking about you're looking at the prefabrication on the building up in Canberra, and how much the services installation was part of that chain, and how improvement should be, maybe there are improvements in that area. So the question here was about how designers marry the push for small depth floor systems, e.g. 300 mil, and the integration of building services. I wonder if you had any thoughts there also about how we can get improvement in that sort of service type sector to get the building done quicker, and if timber can help there.
Floor to floor height, and there are two different discussions. One is the residential discussion where floor to floor height is crucial, and the internal clear space is crucial. So that means the floor needs to be as shallow as possible. In the commercial and the office space environment, it's a little bit more flexible. There again, what I kind of try to say in one of the diagrams, it's actually making sure that knowledge from a services perspective goes into the design process very, very early. And how can we do that? It's really looking into a systems approach, and the systems approach is not only a structural system, it's a building system, which really includes the services work stream, because it's such a high portion of the overall build cost. So it needs to be addressed early. And what I saw in the past, you've got detailed line items in cost plan about ironmongery and door frame and architraves. And then you get to the page of services and you got one line item, services, because it's such in a way, in the design process, still a black box. In a way, it's one line item, but it represents 25% of the cost.
Mm. And another message I heard quite clearly from what you said today, and seeing what's happening in that sort of broader life cycle interest at the moment. I mean, embodied carbon is quite of interest, but definitely that sort of end of life and circular economy is an important one. And I think that design for deconstruction is a real opportunity for timber buildings, particularly mass timber buildings, which will have a huge value in 50 years' time, 100 years' time. Yeah, just keen to get your thoughts there as we finish up. Particularly, I mean, I think that sort of 100-year rule about sequestration, I mean, that needs to be challenged, because even if a building is, mass building is demolished or deconstructed in 50 years, 75 years, those products have, quite good use in this next phase. That should be recognised.
Yeah, there's, as I said before, there's so much work to be done. If you look into where is the timber industry here in Australia with is it included in the MECLA discussion? Here, MECLA looks specifically into the whole embodied carbon story, comes out of New South Wales originally. There's very little representation of the timber industry, so we have to challenge that and bring that argument forward. At the same time, I think the industry needs to do the homework again. So it's really getting certainty and a unified response across the globe about sequestration. Because if I look into the LCAs, and you go one-click LCAs, other softwares, you look into the EPDs of certain manufacturers, you get different values all over the place. It's all over the shop. So there is no kind of unified response as yet. So that needs to be step one, I reckon. And then you can bring forward an argument as well to the wider industry.
That's certainly an area that's important to industry that we need to be concentrating on the moment. Look, we're just on 12 o'clock, so I'd like to thank you, Karl-Heinz, for an absolutely terrific presentation. It's always a privilege to hear you speak, and thanks for giving up your time. I know how busy you are, but I'm sure on behalf of all the audience, we've really participated in your wise words, so thank you very much. So just a reminder to participants that the recordings are made of each of these webinars, so it'll go up over the next week, so you can access that from the WoodSolutions website. Please encourage some of your colleagues to view it as well. It's been a terrific webinar, and I'm very fortunate to have Karl-Heinz. Just a reminder also that our next webinar in 2 weeks' time, so the 18th of October, it will be on structural timber, where we are and where we are heading, with Timothy Allen, a senior structural engineer with TTW. So again, a sort of good transition on from today's webinar today. So I encourage you to participate in that one. So thank you, everyone. Once again, have a great day and a great week, and really appreciate you joining us, and look forward to seeing you at the next webinars.